In this video, we're going to talk about LED safety, and by that I mean protecting your LEDs so they don't burn out, not really protecting you as a human being from LEDs. So an LED is a light-emitting diode. Its schematic symbol looks like this. You'll see this right away in lab number 2. It's a triangle with a little flat line at the bottom, has two arrows going out indicating that light is being emitted, hence the name light-emitting diode. Now in real life, it looks a little bit different, obviously. This is actually a real-life LED that you would see. You have a bunch of them in your kit. They're clear normally, but whenever power is applied to them, when a voltage is applied, they actually will glow a certain color, emit a certain color. Now, if you were to go and just plug an LED across a voltage source, like we're going to do in this video right here, not necessarily good things are going to happen. So right here we have the power supply hooked up across the two rails. So basically, ground is on the blue rail, and 3.3 volts is on the red rail right there, and I just plug that LED in directly across the power rails. So you can see the light is actually changing. It's flickering a bit. And any time in life that something flickers, that usually means either like a bad thing's about to happen or there's a part in a movie that's going to be a problem. So the lesson is you don't want to put an LED directly into across 3.3 volts or any sort of power source. Instead, what you always want to do is use a resistor. That's the correct answer. So you're going to want to put a resistor in series with your LED, and 200 ohms usually works. And so in order to do that in real life, here's an example. So this resistor, if the freaking camera would focus on it, is red, black, brown, which is 200 ohms. And so you plug that into your 3.3 line. You then plug the other leg of that resistor into some sort of breadboard spot. Okay. Then in the same electrical node of the breadboard, plug in your LED. Long leg is positive, short leg is ground, and then it glows and it's nice. Now what about other LEDs? That was a red one. Blue and white LEDs, you could actually probably get away with putting them directly across 3.3 volts, and they'll be okay, but we're still going to recommend you use a resistor. Part of the reason is if you were to go off and do like 9 volts across a white LED, you would blow it up. So it's just good practice to always have some sort of current limiting resistor in your circuit to make life good. Now an interesting thing to keep in mind is right here, we were just talking about LEDs directly wired to the power supply, so like 3.3 volts, but you can also use them with our GPIO pins, which you will read about in Lab 2. And all of our GPIO pins on our Raspberry Pi, as we've set it up, have an inbuilt resistor, so you don't actually need to use a resistor when attaching an LED directly to a GPIO pin. So right here, as you can see, the LED goes into pin 4, GPIO pin 4, the long leg to 4, the short leg to ground.